Okay, so hi again, and this is the Chipmaster. And in this video, again, I'll be doing another repair. I got some laptops from shipped to me locally from another repair shop. Right? I don't know how many laptops are there in there, so I'll have to unbox and see how many laptops are in there to repair. Right, so I will get the cutting knife. Okay, so I have a old school HP Pavilion 17 G7. I think this is a G7, right? Yes, HP Pavilion G7, as you can see. All right, so this one is, they said that they're not turning on. The tech that ship send it to me says it's not turning on. I have here a Asus. I don't even remember what he said happened to this one. Maybe not turning on as well. All right, that's two. This is a Acer Chromebook, 15-inch. I believe this is dead. These are normally prone to die due to that bad power delivery chip there. 7447 or A3449. How many that's three? The fourth one, this is an Acer, and maybe that's not turning on also. And we have the last one here, a Lenovo, and this is an IdeaPad. And this one maybe not turning on as well, innit? All right, so which one should I start with first? Which one should I start with? I'm gonna do an old school. I'm gonna repair the old school. A long time I haven't repaired an old school laptop. So this should be a fun repair, innit? All right, so this is, I'm gonna select this one to repair out of the five. All right, so this is an old school. A long time I haven't repaired one of these laptops before. Sorry, it's a long time I haven't repaired one of these laptops. I normally repair the newer laptops like the CPUs with from 8th generation up, or 7th generation, or 12th generation, or even 13th generation. This is a AMD old school. So this is a cabin, this is a Hudson, right? This is a Hudson PCH. AMD cabin, AMD. Alright, so it's an AMD unit. Alright, so let me take it apart and see what I can do. Alright. Alright, so this one has a screw that's not coming out. I know these laptops are known for that bad hinges there that supports the hinges always break. So I know this is going to fall apart immediately as the screws are beginning to remove from the laptop and the housing gets a bit weak. Yeah. Okay, so almost finished here at the back. Then I have to remove the ones under the screw under the keyboard. Well, first of all, let me plug in the charger and see what I get. I don't even know if this is turning on or off or no display or no power. But I believe he told me that they were not turning on, but I don't remember exactly. So I'd have to test them for myself. Alright, so plugging in the charger now. Oh, it's on the other side. Oh, it's on the other side. Sorry. On the other side. Alright, so on the DC power supply there I get 50 milliamp there, as you can see. Let me press the switch. And it's not turning on, as you can see. I'm pressing the switch and I get 50 milliamp on the DC power supply, but it's not turning on. So this one is not, I haven't getting any lights. So there's no lights. Right, there's no light there at the side there. No white lights. Or orange, or yeah, no white lights. There's no lights. I press the switch, it goes up to 40 milliamp. So that's a dead short there, most likely. Oops, see what I'm talking about? It's now falling apart. I will have to be very gentle with this one. Long time I haven't repaired one of these laptops. I haven't seen one in maybe about 2 years. These laptops, these HP pavilions. I think I have another screw here to remove. It's at the back of here. Let me remove this cover here. Oh, we have a lot more screws here. Yeah. These laptops are around from 2011, late 2010, early 2011. With its competitor CPU, which is the Ivy Bridge, which is the 3rd gen of the Intel CPU at the time. Third generation, or you can call it 3rd January. Okay, so that all screws are removed at the back. Alright, so now I should be able to remove the keyboard, and there should be more screws under the keyboard here. Yes, here is one, and it's 2 of them, and here's the other one. 2 screws for the keyboard for the palm rest. Wow, this is bringing back some memories back in the days when these laptops were around, are very popular. Oh, here's a 3rd screw. Alright, so now I'll remove the palm rest. We have a lot of work. I actually have to turn back some work because there's too much work coming into the shop. So I'd have to tell the techs that they need to give me some time so I can finish these outstanding work. Oh, we have a fourth screw here. Alright, so my customers mainly in my country are technicians. So they have repair shops, so they send work to me on a daily basis. Don't tell me that I have another screw here. No, there's no screw. I don't want to bend here because I don't want to rip out this any further. It's already torn. So I want to be gently as possible with this part here because it normally tears the LCD flex here, as you can see, and this is a common issue back in the days with these laptops where, as you can see, the flex, the hinges is broken, as you can see, and after a while it tears the LCD flex ribbon here, right in the groove right here, and that can cause no internal display, as you all know it. Tweezer. Let's use the flat tool here and pry it off. There we go. So I hope this is not broken. I hope all is well with this flex, because if I repair the board, then they'll have to order another one, which is going to cost more money for the customer for the motherboard repair, and also to replace this LCD cable. Alright, this is the USB optical drive. I have one screw here, and this is for the motherboard. Alright, so the board is out. Alright, so first I'm going to do some cold checks. Apple screw? Yes. Alright, cold checking time. Alright, first of all, let me just inspect the board again as usual for any burn, any explosions, any form of liquid intake as usual, as I'm moving around into the standby area here. Alright, it's all clean. Alright, let me go over to the other side. Alright, this is the standby chip, this is the charging chip, this is the RAM supply chip, and all is well. I'm also looking at the EC. Water normally gets inside here because this part faces up under the keyboard. So if any liquid to spill, it normally catches the EC first. Alright, so the EC is good. No liquid intake. Let's head over to the bottom side here of the board. Alright, this is secondary 3 and this is a standby PWM IC for this coil here. This is the 0.95 volts for the AMD. Alright, all is well, so there's no liquid intake, as you can see. Alright, so I'm gonna check all coils. starting with the standby coils 3 and 5. I get 149, or that's the glare there. It's too much glare. Yes, it's too much glare right there. Hope that works. 149 there. This is 147. That's good. So 3 volt and 5 volt is good. This is the battery charging. I got 170. This should be the RAM. No, this is the RAM. 170. This should be the charger. No. All right, let me confirm it. This is the charger. As you can see, the connection is there. This is for the charger, and this is for RAM. All right, this is CPU core. I get 14. All right, this is the integrated graphics, 29. That's all good. And that's for the CPU supply there. I'd have to check the schematic to confirm which power supply is this one. And this is the secondary supply for the FCH, right? So AMD it's FCH, for the Intel it's PCH, right? The FCH stands for Fusion Controller Hub. And this is a secondary supply, which is VDDCR supply, which is supplying 0.95 volts to the PCH, the FCH, sorry. This is the FCH for the AMD, right? So this is the Hudson. And I get 99, so that's good. Let me check the BIOS chip pin number 8. This is the EC linear voltage power supply. And I get 467, that's good. I want to get rid of this glare here. If I could get rid of that glare. 466. I could angle it. Let me see if I... 466. Alright, so the linear supply is good. All is well. Alright, so let me check the common point. Common point is good, 455, 458. I'm going to plug in the charger now. Alright, so as you can see, the current is now 40 milliamp, and I'm not getting the white light at the DC jack here, as you can see. So there's no lights, and all the reading is perfectly intact. Alright, I'm plugging it out, plug it back in again, so I get 40 milliamp there, and it slowly go back to 20 milliamp, and there's no lights. But for this laptop, we have to get the light in order for it to turn on, and there's no lights here. Alright, so I'm going to do some hot checking now. Turn the board this way. Alright, still no lights. 40 milliamp, and it goes to 20 milliamp. Alright, 3 volt and 5 volt is there or not? No 3 volt, no 5 volt, 0.95 volt is there, no 0.95 volts. Alright, so let's check from the DC jack. This is the transient suppressor diode here. Oh, so let's go under the microscope then. All right, so this is the transient suppressor diode right here. All right, see if we're getting some voltage there. So I get 20 volts there, as you can see. Let me see if I can angle the meter so I can get rid of the glare. So 20 volts is coming into the transient suppressor diode here. Right. I'm just trying to see if I can get rid of the glare. Alright, so we have 20 volts there. This MOSFET is the N-channel MOSFET. And this is the gate, 25 volts at the gate. Excellent. 26 volts at the gate. And the output should be 19, 20 volts. Good. Alright, so let me check if the EC, the standby chip, is getting hot. Nope, it's not getting hot. Alright, this is the standby chip. As you can see, it's a TPS 51123A. Very popular standby chip back in the days. Alright, so I'm going to check the EC basic working conditions. Alright, so the EC basic working conditions, we have pin 60, pin 74, and this is the IT8518E, a very common EC chip back in the days as well. So I'm going to check pin number 74. So this is pin 65, right? 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. And I got 3.2 volts there, as you can see. Sorry. Right, so this is the main standby AVCC pin of the EC. Right, pin 75. Let's check the EC reset signal, pin 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I get 2.9 volts. So the EC gets its reset signal. After the EC gets its reset signal and detects the adapter insertion detection signal, then it should automatically turn on the S5 state. Right, so this is the S5. This is our main standby chip, which is going to turn on the S5 state and the standby power supply for the FCH, right, which is VCC VDD 3V3, or you can call it VDD 3V3 S5, right? So I'm going to first check now on pin number 16, I believe. So this is pin number 1. So let's check the main input, pin number 1. This is 5, 10, 15, 16. Is it 16? 5, 10, 15, 5, 10, 15, 16. It's this one? That's a standby. 5, 10, 15, 16. I would have to get the schematic. Let me get the schematic. Okay. Alright, so now I'm on the Shinjijao database here. So I'm going to type in the board number, as you can see. So it's DA0R53MB6E0. Alright, so I got a schematic here. As you can see, it's the Trinity CPU, and we have the Hudson FCH, right? And this is the Trinity APU, right? So AMD is called the APU, and the F South bridge is the FCH, which is the Fusion Controller Hub, and the AP, which is for the advanced processing unit. So I need to find that chip, which is the TPS 51122, 51123. So it's Texas Instruments, so it's TPS 51123A. Here it is. All right, so the input, the main supply input, I was saying that's pin 16. Yes, I was correct. So it's pin number 16. So pin 16 is V in. And I was getting V in from the last MOSFET, as you can see here. So that MOSFET, that was the N-channel MOSFET that is getting the 26 volts, which is the adapter MOSFET, right? And that should be sending that V in pin voltage to pin number 16, right? So let me go to pin number 16 again, because I should be getting that 26, that 16, that 90, 20 volts there at pin number 16. All right, so this is the standby chip, and this is our this is our standby chip. That was the charging chip. So pin number 16, this is pin number 1. Let me go back some more. All right, so pin number 1 is here. That's 5, 10, 15, 16. And I'm getting 0 volts. Interesting. There's no voltage there at pin number 16. And I also checked the 19 volt rail, or the common point, for shorting. Let me double check again for any shorting that is going to be there. Right. So I'm going to check for shorting now. Pin number 16. And I get 100. And it's slowly going up because the charger was there. So it's discharging the line. And it should be around 400. It's discharging. So I'm not getting 16 volts, 20 volts there, sorry. Not getting 20 volts at pin number 16. So 2, 3, that's the wrong pin I was checking. Hold on. 1, 2, 3, 4, 5, 6. So it's not pin number 16. So it's 6, it's 12. Oh my God. 12, 13, 14, 15, 16. The wrong pin. I was at the wrong pin. Sorry about that, guys. I thought it was 5. I'm just used to the older chips, the newer chips, which is the SY8286. So that's 12, 13, 14, 15, 16. That pin that I was checking was a boost pin, seems to me, because it was discharging very slowly. Alright, so pin number 16. I get 20 volts there, as you can. Oops. So I got 20 volts there at pin number 16. Alright, so, and I get the linear voltage of 3.3 volts at the BIOS chip. So basically what this is saying to me that the 5 volts and 3 volts is going to come after pressing the switch. Right, so after pressing the switch, 3 volts and 5 volts will be there. Right, so this is 5 volt and 3 volt section, as you can see right here. And this voltage is going to be present after pressing the switch, but we need to get the lights first at the DC jack. So these voltage are going to be turned on after pressing the switch. The EC will release the S5 on command to this standby chip to turn on 3 volt and 5 volt standby. So I'm going to check the working conditions of the charging IC now. Right, so this voltage, when it was going to 40 milliamp and going back to 20 milliamp, the 3 volt and 5 volt was produced already. And then it will shut down and wait for the user to press the switch. So look at this mechanism. So I press the switch, plug in the charger, I get 30 milliamp, as you can see. Right, and then it slowly goes back to 10 milliamp or 15 thereabout milliamp. Right, so I'm plugging it out again. So as I plug in the charger, right, it goes to 20 milliamp and goes back to 0 again one more time. All right, it goes to 20 milliamp, and then it goes back to about 15 to 16 or 10 milliamp there, I'm not sure. And then now wait for us to press the switch. But as I said before, in order to get, we have to have the white light. We're not getting the white light, so we need that white light for this board to be triggered. Okay, so please bear that in mind. So 3 volt and 5 volt is generated after the switch. So I'm going to check the working conditions of the charging chip. Well, the charging chip is controlling the MOSFET, so it's basically turning on that N-channel MOSFET. I'm just going to check pin number 6, which is the adapter insertion and detection signal. So pin number 6, 1, 2, 3, 4. Yeah. So that's a BQ. So that charging chip is a BQ728. So I'm going to check 1, 2. So that's 1, 2, 3, 4, 5, 6. And I get 2.8 volts, and that's correct, because the voltage should be between 2.4 to 3.3 volts. If it's below 2.4 volts, it's not a valid insertion detection signal. And if it's above 3.4 volts, that's also not a valid detection signal. So that simply means that our adapter voltage must not be below 17.46 volts. All right, so if it's below 17.46 volts, then that's not a valid adapter insertion detection signal, which is going to be way below 2.4 volts. Okay, so the EC now is responsible for turning on that light. Could it be that the BIOS is corrupted? Maybe. All right, so I'm getting the switch, taking out the switch out of the palm rest. Right, connecting the switch to the board. Right, so that's when I get just have it ready. Oh, I'm seeing something now. When I press the switch, the light is flashing at the side of the DC jack here. So I'm pressing the switch. So if you look, as you can see, there's a light flashing there. That indicates that normally when the battery is low, you will get this light indicating that there's a low battery there. But the charger is in, and it should turn on. The light should be emitted immediately as I plug in the charger. Now when I press the switch, as you can see, it is flashing, and the current is now 40 milliamp, as you can see on the DC power supply. Okay. All right, so I'm going to go and see if the EC, so the EC gets supply, you get reset, it has an internal clock, and then after getting the adapter insertion detection signal, then it will turn on the S5 state, right? So the linear voltage is produced, so I will need to check adapter insertion detection signal coming into the EC, which is at the AC in pin, right? So let's get back to the schematic. So the EC pin, we go to the normal AVCC to find the EC quickly, AVCC, and that's pin 674. Okay, so the AC in pin is input pin. We have S5 on. This is the key signal that we are going to need. So after we press the switch, the EC will release S5 on, and that A signal will go to the standby chip TPS51123. So we are pressing the switch. This is a signal that was pressing a while ago while the light was flashing. Right, it says from power button, right, NB switch on or notebook switch on. So this is a common quanta, right? This is a quanta naming convention for this board. So we have AC in, right? So this is AC in. It should be an input pin, not an output. This should be an input which is coming from the charging section. So let me check pin number 21 on it and then see. We should get 3 volts there at pin 21. Pin 21. Pin 21. So this is pin number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And I'm not getting any volts there at pin 21. Let me confirm the pin again on the schematic. Yes, it's pin 21. All right, let me recount again. Let me go back to the, yes. So pin 21. Get my, all right, so pin 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And I'm getting 0 volts. Some boards that is normal, especially on the Wistron boards, the signal has to be valid low for the EC to detect a valid adapter insertion signal, because it's after releasing from the charging IC, then it will go to an N-channel MOSFET where the source is connected to ground. After the 3.3 volts from the charger IC AC OK signal goes to that MOSFET, it will turn it on and ground out the signal, and that's a valid insertion detection signal. But for the Quanta boards, let's get back to the schematic. Let's check and backtrack where this that's not the schematic. All right, so AC in. Let's search. All right, so AC in is coming to this diode here. As you can see, the asterisk, that means that diode is not installed. Right, the asterisks on this Quanta, on the Quanta boards, indicate that the component is not there. All right, let's move on. All right, so it's coming from our charging IC, as you can see, AC PRES, which is the adapter presence signal, or adapter presence, or adapter insertion out signal here. This is an output pin, as you can see. And this is RGEVEN, RGEN 6 volts, so this is a linear voltage, right? And this voltage is generated from the charging chip from this section here, as you can see, REGN 6 volts. So 6 volts comes out of pin number 16 to this capacitor, and it is going to this boost capacitor diode here to boost, as you can see, BTST, to pull up the BQ high drive pin of this gate on PQ31, right? So it is coming here to add 6 volts to the 19 volts, which is coming from this pin, CMSRC. Okay? So let me get my pointer fix. Let me get my pointer fix. Okay. Where am I? All right. So as you can see, so this voltage is an output voltage coming out of the charging chip. Once it gets V in, All right, once it gets to main supply, and it gets adapter insertion detection, which is AC. Sorry, not that one. Zoom out a bit. So the input pin, which is VCC. So we get VCC, which is 20 volts coming in, and we get adapter presence, which is AC detect, pin number 4, 6. So pin number 6. So as you can see, pin number 6 is coming in through a voltage divider, and this is 2.8 volts that we get. 2.8 volts. After that 2.8 volts comes in, right? First you get the supply, we get 20 volts, right? And that 20 volts is coming through this voltage divider here to pull it down to 2.8 volts. After these two voltages are okay, then the chip will automatically release this voltage, 6 volts, right? So this is 6 volts coming out of the chip, and it's going back to this chip, as you can see, going back to the chip internally to boost, to pull up, right? And it get 19 volts. This is CMSRC, which is coming from our 19 volt rail. So 19 plus this 6 volts coming in is going to give us 26 volts, right? So that is how it is calculated internally. If you read the data sheet, you should be able to figure that out and get that information from the data sheet, and that is used to pull up this gate of this upper MOSFET here, PQ31. Right, so this is my focus here now. We have RGEN 6 volts, which is coming through a voltage divider. After coming through the voltage divider here, it will output 3.3 volts, or 3 volts there, roughly, between 3.3 volts to 3 volts, which is coming out of this charging chip to go to the EC, to tell the EC that the adapter is present, right? So this is not a low signal. So this is a high signal of 3.3 or 3 volts, but I'm not getting it. So I will need to go back to the charging chip, and then I will check pin number 4, pin number 5, and see if we're getting it. All right. So I'm going over to the charging chip now. Charging chip. All right, so here's the charging chip. So I'm going to check pin number 5, resistance. All right, pin number 5. This is pin number 1. 2, 3, 4, 5. And I get 435. And that's good. And this is a pull-up resistor. As I said before, it's coming through a voltage divider. Right? So let's check the voltage there. Pin number 5. And I'm not getting any voltage. No voltage there. This is a pull-up line. So this should be my fault, isn't it? So I'm getting 6 volts. So let's check the working conditions. So first, I get adapter insertion detection. Oops, is that grounded? I wasn't getting any ground. This charger is in. The charger is in. Pin number 6, 0 volts. That's not normal. I was getting voltage there. Bias chip pin number 8. My charger is plugged out. No, everything is intact on the charger line, so should be working. Oh, I'm on AC voltage. Sorry, I was on AC voltage. My gear was on AC voltage. Sorry. So I'm checking pin number 5. I'm not getting anything. AC in. Still no voltage. Let me check if I'm getting 19 volts from the tip of my charger. Yes, I'm getting 20 volts coming out, but it's not going into the board, or not. Let me check again. Pin number 6. Oh yes, I'm getting 2.8 volt now. Pin number 5. No 3.3 volts. Right? Let me check if I'm getting 6 volts coming out. Yes, I get 6 volts coming out of the charging chip. This is the boost diode. Right? So I get the main supply, 20 volts. I get adapter insertion and detection, 2.8 volts. I get the linear voltage of 6 volts, but I'm not getting the adapter present signal, pin number 5. So I need to check the voltage divider that is coming through based on the schematic that is telling me. So let me go back to the schematic. So pin number 5, I get the 6, so we need to check if 6 volts is coming through this 100k resistor. And it's coming through, after coming through this 100k resistor, this 100k resistor is splitting the voltage in half, so you can see 100k and we have 100k here, so that's going to split 6 volts in half, so that's 3 volts. So it's 3 volts coming out of the circuit, because we have two 100k resistor here. So we should get 3 volts coming out of this circuit, coming out of this small circuit here, to go to the EC, to tell it that the adapter is present. So I need to find PR80 and I need to find PR79. Right, to see if I am getting 3 volts, to see if the resistance is okay, if it changes value, if the resistors change value. So I need to find PR79, so I'm looking at it now under the microscope. Alright, so PR79 is here, and we have PR80 which is here, and this is pointing to this circuit here. So this is the circuit. So PR80 is, so as you trace the line, right, it's coming up here. So PR80 should be this one. This should be PR80, and this should be PR79. So let me see. One side should be connected to ground. Alright, one side should be connected to ground. Okay, so this side is connected to ground. So this side should give me 6 volts. After coming through the 6 volts here, it should be connected to here. So let's check that voltage. Alright, so I'm going to check the voltage now. So this side should give me 6 volts. I'm not getting 6 volts. Oh, sorry, here's the 6 volts. And it should leave here and come here, but it's 0 volts. So 6 volts is here. This side is not giving me 6 volts. So let's check this resistor. If it's, so I should get 100k there. It's now 48 minutes in the video. And I get 79. And this one should give me 100k as well. 100 ohms. 115 ohms. 121. Let me remove that out of the circuit and check it. That's not normal. So I can get an accurate reading. So I'm just going to remove both of them and check them. I'm just going to lift one leg. All right, so I removed them, just disconnecting one of the legs. Sorry about that, I was on a text message. All right, so I'm gonna check, and I get 100 kilo ohm. I don't know if you can see it, but if you keep an eye there at the top corner here, it's on mega ohms now by default. And I'm gonna check it, it goes to, so I get 94K, so that's good. I'll see if I want to get rid of this anti-glare. Oh, I know what I can do. Turn off this light. This should get rid of the anti-glare. That should get rid of the glare. All right, so I'm checking again. I get 100, and that's 99.5, and that's roughly 100 kilo ohm. That's good. This one now, and that's 100 kilo ohm. Also good. So could it be about the charging IC is pulling down that voltage? Let me see if I get in a direct connection in continuity. Yes, so I'm getting a direct connection. So the resistors are okay. So I'm just going to solder them back into their position. All right, there we go. All right, so plugging in the power now. Checking again. 6 volts on this side. Oops. Six volts on this side. Yes, 6 volts. Output side, no voltage. I should be getting 3 volts here. So I'm going to remove the charging chip. And there's no short there. I'm going to change the charging chip. Alright, so tinning the pads now with some leaded solder. let it solder balls. Ouch. Let it solder. So I'm going to get the chip and be right back. Okay, so I have here a board, but it's not close. It's not the exact board, but it turns on, all of them turn on the N-channel MOSFETs. BQ725A. So this is the BQ725A. All right. Trying to get the focus here. It's kind of a bit hard. Let me clean the surface with some 99. All right, so as you can see, there it's a BQ25A. So I'm going to use this one. This one can work as well. Right, and then onto this part. All right, so I'm just soldering it now. Let's do this. Removing these excess solder. All right. Just cleaning this part now. All right, just inspecting the solder connections, making sure that all the legs are, everything is soldered correctly. I'm seeing some extra, a bit thick. I want all of them to be even. All right, there we go. All right, let me measure the resistances. All right, input pin. All right, very good. Pin number 5, 430. Okay. Pin number 6, 491. That's good. Yeah, all good. All right, so I'm going to plug in the charger now. and I'm still not getting any lights. Pin number 5, 0 volts. Pin number 6, 0 volts. Pin number 24, 6 volts. No adapter insertion detection. Really? Not getting any voltage at pin number 6. Okay. Oh, here it is now. Pin number 6. Takes a while to get there. But the voltage is not coming over. I'm gonna hold this with my tweezer and see if I get any feedback. And there's still no lights at the DC jack. I'll have to pause the video and then figure this one out and get back to you because I'm over an hour now in the video. Okay, so upon testing, right, so I injected 3 volts manually. I removed that pull-up resistor from the voltage divider that is taking the 6 volt linear to the EC, and I will switch it on and then add my voltage, regular 20 volts. So I give power. So as you can see, I get the white light now. Right, so I got that white light, as you can see, and I press the switch and it turns on, I believe. As you can see, I'm getting 1 amp there. So I'm getting 1.2 amp and the board is perfectly on. So I use my other DC power supply to inject 3.3 volts into the adapter insertion detection signal, and I got the white light. So as you can see, I give power, I got the white light, and I'm gonna remove 3.3 volts. As you can see, the white light is gone and the current is back to 30 milliamp, and then it slowly goes back to 1 milliamp, and I give power. So if I force 3.3 volts in this side, it should work, innit? And that's how I tested the circuit and found to see if there was a short. So I thought that the EC was bad, right? So I was going to remove the EC and inject 3.3 volts and plug in the charge and see if that 3 volts adapter insertion AC in detection signal is present. And then I say I would first want to inject 3.3 volts manually and see what happens. All right, so the resistors are okay, as I measured them before. Right, everything is okay. I put back the original charging IC back on the board, right, and as you can see, the board is working fine when I inject 3.3 volts manually into the AC in detection section there. Okay, so I'm just going to remove that back. Right, I'm going to put back the resistor there, 100K resistor. Okay, so that was a tough one. So I went through the board thoroughly and the schematic, and I found out that this chip, let me go under the microscope. So this chip here was the culprit, and that's PU12. And when I check the schematic, yes, yeah, me see it, me come here. Sorry about that. Sorry about that call came in. All right, so the AC in signal was coming to this chip, pin number 15, and each time I removed the charger, the resistance was slowly discharging back to normal. So I Didn't want to remove the EC first because I don't know if it's the EC causing it or this chip. So it was easier to remove this chip. So after removing this chip, the resistance instantly went up back to 315 ohms there. And I plugged in the charger and the 3 volts came and the AC in the signal was okay. So this chip was the problem, and that was PU12, right? And that's this chip here, right? So this chip is the chip that is responsible after pressing the switch. It gets the S5 on, it gets sus on, main on, and turn on the S0 state voltages, right? So this is the chip. This is a Quanta design, only Quanta. All the Quanta boards have this chip, right? This chip is designed. This chip is originally implemented in the Quanta boards, right? Back in those days. So this chip is just to turn on the S0 state, right? So from S0, S5, sorry, to S0 state. So after replacing that chip, I got the light. So let me plug it in now. There we go. So I have lights, and I'm going to press the switch and fan spinning, and you can see the current is now 1.1 ampere. Right, so I think the job is done. So after replacing that chip, I got the white light. So as you can see there, that was a tough repair, and that was the first board I actually selected out of the 5, and I have 4 more to repair. I'm going to see if I can do another one and then lunch, and I have another one for another repair shop that is important, so I'm going to do one more and that one, and then I will call it a day because I'm the only one working here today, right? The worker doesn't work here on a Saturday, or on a weekends rather, so it's me alone. All right, so I'm going to put this unit back together and test it and see what I get. Okay, so I'm now adding the last set of screws, connecting the hard drive. Cover for the hard drive case. And the battery. All right, so as I gently open, I have to hold this side because the hinge support there is broken. All right, so shall we? Ready? All right, so I'm gonna plug in the charger now. All right, I get orange light, and I get 140 milliamps. So the battery is charging, as you can see. Right, so pressing the switch now. All right, there we go. All right, so we have Windows starting up there. The brightness has decreased a bit, and we are getting 2.1 amp fluctuating. The battery is charging. Yeah, it's charging. All right, so you have our mouse is there. Yeah, starting up. That's it. Seems something is wrong with the operating system or something. Let's give it some more time. Well, I guess I see. Seems that the operating system is. Oh no. Guess what? I unplugged the cable now. But I held it. Let me pause. Alright, so the cable wasn't unplugged. I just powered down and powered on back, and I got the Dell logo there. So let me see what I'm gonna get now. It's a long time I haven't repaired one of these old school machines. A very long time. Maybe about more than maybe 5 years since I've repaired one of these laptops. It's taking a bit long. We are in 3 amp now, so the battery is charging up. So I have mouse pointer there. It's taking a while. But anyway, it's repaired. It was dead, no power, right? And it's now fixed. Oh, there we go. It's a bit slow. It only has 4 gig of RAMs in it, one stick. So that is why it's so slow. And maybe it has a lot of data on it as well. Alright, so I hope you enjoyed the video. And please like and subscribe as usual. And there we go. And in the next video, I will repair something for you. Okay then? Bye.